3 months a webinar on technical WASH subjects that we didn't invent. There are subjects that were shared back in January of this year, actually, in almost a year, during the humanitarian WASH workshops organized by the Veolia Foundation and the French Water Partnership. They are every 2 years rendezvous where we meet in person and kind of discuss, exchange, debate, demonstrate, learn about WASH subjects and new innovative things that have happened, come out, emerge in the last couple of years. And during this edition in January 2025, we alongside other colleagues, including Marine Meudry from SCF, who I saw was in the webinar. It's great to have you here. We organized thematic discussions around the thematic of waste, energy, and WASH. And we came up with a few questions. When I say we, is the different organizations that participated in those debates, questions that arose from the field, that they have from their practices, and that they would be appreciative if we could create the space to debate these together. So after this, we decided to launch this series of webinars. The first one took place in September around the topic of desalination. So we talked a lot about RO, but not only. And today we are going to focus on the theme of energy and especially on the topic of solar technologies. So that includes solar pumping, but also solar cooking and solar dryer as well. And for that, we've decided to invite, and thank you so much for the people that have been telling us about different experts and different people that we could invite. It's really a teamwork here to have such a great panel. So we've invited Vikash Pandey, the Director of the Clean Energy and Circular Economy at Windbrook International, as well as Alberto Ibanez, the Clean Energy and WASH Program Manager in Ivory Coast for IOM. And from ACF, we've got Brice Privot and Adam Pettigrew from the ACF. So Brice is WASH Regional Advisor and Adam is the Electrical Rehabilitation Field Coordinator. So the plan with today's session is that each of them, actually Brice and Adam will be together. They're doing a Teams presentation. They will present a project from the field, some learns, feedback from experience of what they have been dealing with in terms of solar technology. They will be speaking about 10 minutes top per person, maybe 7, that would be amazing. And by 2:30, or depending where you're based, but in about, well, actually 30 minutes, we should open the Q&A. So in the audience, feel free to send your questions in the chat. So you can also keep them in your head and then raise your hand whenever the Q&A starts and ask them to our experts. This is really meant to be a participatory webinar. So we really appreciate it if we could have some great discussion afterwards. Thank you so much. And with that, I give the floor to Vikash. Each of you have your own presentation and we welcome you to share your screen. The first presentation from Vikash will be on the model for solarizing existing pumps currently running on diesel. And I believe it is an example from Ethiopia in a rural setting. Vikash, the floor is yours.
Okay. Can you see my screen?
Yes. Oh,
Are you able to see my screen?
Could you put it in?
Yeah.
Could you have it in full screen
yeah.
if that's possible? That'd be amazing. Thanks.
Sure. Yeah. Okay. Yeah, so good afternoon, good evening, good morning. I am speaking on the financing aspects of solar pumps for WASH and have an example from Ethiopia to present. And the objective of our project there is to leverage private investment through a lease-to-own model. Our objective has been to demonstrate a scalable commercial business model for solarizing diesel community water supply. So in the current situation, many diesel pumps are running. They were constructed with grants, and the government requires the communities to pay the diesel fuel. So our business model is based on the fact that if they were to pay for a solar pump instead of continuing to pay for diesel, they could purchase their solar system in 3 years. So our theory of change, if rural communities continue to pay the same or lower tariff they're currently paying to cover diesel fuel and operation maintenance of diesel, and the risk to private solar developers for investing in community solar pumps can be reduced through technical assistance and some results-based grants, then rural water associations, water utilities can purchase a solar water pump and pay back the cost in 3 years. And this will accelerate the solarization, so people are not waiting for grant-funded systems. Here is our business model. The main actors here are the zone Wareda administration. These are the district administrators, and they were the ones that initially constructed the entire water supply system. And their job is to support the communities to invest in this model. Each community has a water committee or a water association, and they have to provide 10% of the cost as a down payment, and then operating the water system and collect the revenue, and then pay the installment costs to the companies. And then the private solar vendor mobilizes the financing, installs the system, and maintains the community water pump for the 3 years. And after that, they can have a commercial arrangement between the two, between the company and the communities. So our life cycle cost comparison shows that, while the solar pump is more expensive than the diesel, its lower cost in terms of replacements, O&M, and fuel cost means that communities are saving up to $90,000 US over 20 years compared to the diesel when they make this change. And what we are looking at is we don't believe every community can participate in this program. Some have very high dynamic heads to pump. Some have very small systems where it's not economic. Some don't charge enough tariff to pay for the system, or some cannot pay the 10% down payment. So the left side of the curve is the green, where these are communities where they fulfill these requirements. Excuse me, and they are ready for lease to own model with minor repairs. Those who require major repairs, or they have higher dynamic heads for pumping, and their tariffs, they cannot afford the tariff that's required, they may need grants. But we didn't want to slow down those who can already pay for these systems, while and not require them to pay, not require them to wait for full grants. So here's our 10 pilots done over the last 3 years in different parts of Ethiopia. I provide the details there. And we are just about to start a new phase for 30 systems to expand it to 2 other provinces. We have worked in Amara and Oromia, and we will expand to southern and central with the same model. So that's my presentation. Thank you very much.
Thank you so much, Bikash, for this impressive project and helping us understand why it is cost effective and interesting to look into transforming existing systems into solar energized ones. If you have any questions, reactions, comments, please send them in the chat or keep them for the Q&A, which will happen soon. I'd like to give the floor now to Alberto from IOM. Are you there, Alberto?
I'm here, Solaires.
Amazing.
Yes.
You're going to be telling us about the integration of a Li-ion battery into solar pumping, right?
Yes. Let me just find the presentation. You see it there?
Yes, we can see your screen. If you could also put it in full screen, that'd be amazing. Thank you.
Okay. So I'm going to try to make this in the 7 or 8 minutes that you mentioned. That's a big challenge, but let's see if I manage.
Really appreciate it.
Hello to everyone. My name is Alberto Ibanez. I'm a project manager with the International Organization for Migration, and I'm going to present a concept that we call multipurpose solar power water pumping schemes. For about 10 years, we have been working in the promotion of solar pumping technology across the WASH cluster. We have made a lot of installations ourselves, and one of the things that we realized when we were brainstorming to see, what would be the next step for solar pumping schemes, is that when you connect a pump to a solar panel, if the yellow line here is the power provided by solar panels, and the dotted lines are the minimum and maximum power capacity of the water pump that is connected in the scheme. In literally every single solar pumping schemes, there are an amount of energy that, because it is too little or because it is too much for the pump, is never used. Yeah, and so we started an exercise to evaluate how much energy was not used in solar pumping schemes that were already functional in the field. So we made this study with 5 existing solar pumping schemes in Ethiopia, Yemen, and Nigeria of different sizes. I'm going to focus on the first one in Ethiopia. That was a 4 kilowatt water pump that was connected to a 9 kilowatt solar PV array. And what we realized is that when this pump was running and providing the water that the scheme was designed for, there was like 6 kilowatt hour per day that was not of energy that was not used. Yeah, and this happened, as I say, in nearly all solar pumping schemes when they are well designed, not because the panels have been oversized, not because the design was not fit to purpose. It happened because when we design solar pumping schemes, our aim is to provide a certain amount of water. We are not focusing on providing energy, we are focusing on providing water. Yeah. And so what we could do with that surplus and use energy in, for example, this scheme in Ethiopia, we made this theoretical exercise where we could charge 300 phones in the community. We could have 10 lights working for 8 hours a day. We could have a TV and ceiling fans, for example, for a community center. Yeah. And here, what I say 15%, this is the energy, the surplus energy that we could have when the pump is not working during the solar day, on average. So let's say that the water tank is full at 3 p.m., and then we stop the pump, we have the whole solar array there, good for nothing. If we could collect that energy when the pump is not working and use it for other things, we could have a 15% extra energy to this 6 kilowatt hour per day. Yeah, and so for all the other pumps. So we realized, okay, there is a sizable amount of energy that is already available at community level with equipment that is already at the community. So could we retrofit that schemes to provide this concept of solar community hub? Yeah, so retrofitting solar pumping schemes so that they became energy hubs. Yeah, where the community can do a number of things. So one of the first things that we realized when we started piloting this concept is that we were going to need batteries. Batteries today fitted to the context where we normally work are lithium-ion batteries, whose price have decreased on the same scale than it happened with solar PV panels. Yeah, as you know, solar PV panels price have collapsed since the 70s. For the last 10 years, keep coming down. Because of high use of solar panels, economy of scales, more efficient manufacturing process, and so on. And exactly the same thing has happened with lithium-ion batteries. So our next step was, okay, let's retrofit a few solar pumping schemes with a few batteries and see what we can do with it. So for this, we went to Kenya and Zimbabwe in 5 different locations. where we ran some field surveys to see, the most pressing energy needs at community level. And these were, as you see there, at family level, health clinic, and school level, was about lighting, phone charging, device charging, were things that might sound simple, but were life-changing for the communities or for these facilities. Specifically in Zimbabwe, I recall that communities people will take like a week to charge their phones, or schools, they will not have light to study at night. These kind of things. Yeah. So what we did is okay, let's retrofit the solar pumping scheme, and a little bit summarize on a couple of pilots. This one was in Zimbabwe, where there was a potential to charge 150 phones per day. The other thing that worked well here was the fact that the water committee itself was managing this extra access to energy service. So we didn't have to work on creating a management model, a committee, how you are going to collect fees. It's the water committee itself that was already established, that was already doing these things for water, that will manage also to collect fees to access energy, fees that were agreed at community level. Yeah. So, for example, for this one, you have 150 phones. The charge per charging a phone was 0.110 cents of a euro. So the revenue per day was 15 euros. And then there were some portable batteries that they could take home for different things. And there was some needs at the school that were provided for free. Because the community agreed that school will have access to energy for free, and then they were not using all the energy that was available at the water pumping scheme level, but they could, what I call here the potential to happen, they could be doing these kind of things or others. This survey that I'm showing here, it was the first months after installation. So with the energy available that was not used by the pump, is this amount here, 5.8 kilowatt hour per day. The potential revenue that they could have just with these activities, with the price they agreed on, was like 30 euros per day, or 10,000, almost 11,000 euros per year as an average. Yeah. The same thing for another case in Kenya, where difference with the Zimbabwean example, the farmer committee decided to buy a solar milling device so that farmers could mill the grain at half the price than to the diesel generator power facility that was available in another village, and the potential revenue on charging phones, renting portable batteries, and using the solar milling was about nearly 50 euros per day, or 17,000 euros a year. Yeah, the cost for us to retrofit this system was on average, with a 12 kilowatt hour battery pack, was around 15,000 euros. So it's not affordable as a capital cost for the communities. But I mean, these were pilots, so the potential to break even here was quite high. Yeah. We made some comparative analysis in terms of finance. We were saying, okay, let's see what will happen if we use these batteries as a substitute of diesel generators when we have hybrid systems. Yeah. As you know, solar pumping schemes, if you want to pump water beyond the solar day, in most off-grid cases, we will have a diesel generator working there. So we were comparing, okay, for the case in Zimbabwe, that was a 2.2 kilowatt pump with a 2 kilowatt hour battery pack. With this battery pack, we could pump 5.5 hours per night or per day, as you want. I say here night pumping. Yeah. What would be the cost of having that system pumping at night 5.5 hours with a diesel generator? Will it be still, financially speaking, better to use a generator, or we will start thinking replacing generators with battery packs? And this is the life cycle cost analysis, taking the real cost, the real interest of the country and cost in the country, where you can see the orange line is the solar array fitted with the lithium-ion batteries with a lifespan, an average lifespan. We were using Solaires batteries of around 11 years, where you could break even at 1.3 years, and then you have cost saving compared with the solar plus diesel generator option to provide the same amount of water. We'll be saving around $17,000 after 5 years, 32 after 10, and so on. On the right, there is the same kind of financial analysis for the system. This is a pump of 5.5 kilowatts fitted with a 48 kilowatt hour battery pack that could provide pumping for 8.7 hours during the night. And if we provide that same with a diesel generator, that will be the blue line. Yeah, and you see the break-even point is slightly longer, but the cost savings again $25,000 after 5 years, and so on. And we are not putting into this finance analysis, the process of bringing diesel, and all the logistics within the organization, the logistic cost to maintain a diesel generator. So that will make also sense in terms of finance to start thinking of using this kind of technology instead of diesel generators for a small system, even if it is just. And this is my last slide. So, what are the benefits of this model? Well, one of the things that we heard about many times in the last 10 years is that, some communities just turn on the pump. This is a solar pump that costs nothing. And so there is a lot of water waste. Here, there is an incentive to better manage the water resource, because when you switch off the pump, then you can accumulate more energy that you can use for other things. Yeah. So that also opened the way to more options for social engineering, better avenues for increasing financial sustainability of the system, and so on. Yeah. So that is it. Thank you very much for your attention, and over to you.
Thank you so much, Alberto. That was very concrete and complete. I think it's great to see such a tangible example and what it means in terms of numbers, where the impacts go, and how we could go beyond really the energy aspect of it. So thank you very much. And now, last but not least, we're welcoming ACF for their presentation. And I'm going to use the argument from the two people that presented this morning in French, but it is very French indeed to be critical of things. And because they will honor this French legacy, they will be telling us more about the critical points from feedback from the field after a decade of using solar energy technologies directly on the field. Thank you, Brice and Adam.
Thank you very much, Solène. Yes, today, we're having a presentation. Obviously, myself, Adam from ACF, I'm an energy referent, and Brice, who is here from the WASH department, who is also a referent. As you mentioned, Solène, today we're going to be taking the critical approach, some French might say, and we want to reflect on some of the common issues and problems that we've encountered with solar pumps and solar power in general. For a context, in over 20 plus countries of intervention, all of the WASH programming we implement have a water supply component, which is most of the time delivered with solar power. Given the ACF mandate, which implies that we work in health facilities and communities and deliver sustainable and integrated solutions, solar represents a significant part of our activities. With a continuous increase in implementation over the last years, which can represent up to 20% of the operational budgets in some contexts. This volume can come with some successes, but also it can come with many challenges, as we're going to discuss today. Here, following in this presentation, we'll see some of the mistakes and lessons learned, and we're happy to share now. In the first picture here, we can, the bottom left-hand corner looks a little bit like something, a door left over during construction. But on the right-hand side, we've got solar panels which are installed, which makes it near to impossible for the community or anybody to perform maintenance upon this, being so high off the ground to have a switch or supply. Next picture, please. This was a solar water pump that was installed in Nigeria. As you can see, there's good parts, as we all know, Grandfoss pumps, good parts in the installation. However, the implementation was a little bit left a little bit to be desired. As you can see, circuit breakers at the top of this pump and cables that are slightly connected or even missing parts in the bottom right-hand corner. Next slide, please. During this exercise, we tried to write down and copy some of the things that we notice can go wrong in the project lifestyle of a solar pump. As you can see, this is a bit of a dog's breakfast, or as we would say in Australia anyway. But a lot of points that can bring a project undone. That can cause a project to fail, cause quick implementation to happen, and damage the life cycle of the pump or the project. Next slide, please. This was a project lifestyle. And moving on to some technical issues that we've had on solar pumping, whether it be the size of the pump, the installation of the PV installation, electrical problems, the insufficient storage and things like that from the implementation on the technical side. This along with the project implementation can definitely cause a shortened lifespan of any sort of solar project and pump project in general. Now I'll pass on to Brice, who's going to help with some of the solutions we've come to this.
We try to, at least. So we try to identify 4 main axes on which we see recurring issues that, are kind of common to all the projects we could see, and try to come up with a few recommendations you see. But here we'll focus maybe on one by one of the main axes. So for example, on technical issues, we think it's really important to focus on the quality of the data, and especially the quality of the wash data you can gather on your water point when you design. So to have, correct pumping test, to have, correct measurement, etc. All of these are really the foundation of what a good system is. And sometimes, those data can be lacking, or we want to go a bit faster, and we kind of skip the essential, to go, to the next step. And we oversize by 10% at each step to make sure that it's going to be fine, which results in a loss of efficiency, in a loss of money, and often technical issue down the line. So we feel for this, it's really, really important to have a look at that and always have in mind that it's an unskippable step. On competencies and training, so this is really one of the core, let's say, focus on what we need to look at is even if solar is now very widespread, it's common, etc. There is training needed for all the staff, especially wash staff, given the number of technical skills they have to cover. So it's really important to invest into trainings and to have the means for correct sizing. And it's the case in ACF where we try, as you can see, we're presenting both with Adam, which has, electrical specialty, and me, more washed one. And we are in general working in tandem, on our projects. And this is a way to reduce at least a bit of friction, but this has to be done in countries as well. We're trying to have this setup on the ground, but even if it's difficult to fund, it seems same unavoidable to have, those human resources, with the skills that are built over time. We've seen this morning in the French presentation as well, some presentation about specialized consulting that do training for humanitarian team. And this is something we think is really important to look at. On the budget issue, everybody will agree we never have enough money. But outside of this cliche, I think it's also really important to here showcase that we need, as humanitarian actor, to raise the profile of maintenance and how much, having dedicated budget to it is important, and to value it also towards our donor. It's a bit maybe of an advocacy effort that we need, but really, showcasing how much maintenance is actual value for money is something that is really important. And on the monitoring and project life cycle issue, I think we kind of touched upon that already, but it's really important to have, sustainability built into the system from the get-go. And I think it's where we link with what we're trying to do in ACF for WAS, is trying to adapt more a system approach rather than an activity lens. Because often we think we do the water point and then it's done, we have the water committee, we can move forward. But it means that we address only the infrastructure part of it and probably, a bit of the planning. But all of the rest is kind of, left out. So we're trying to have that, notably also to avoid negative side effects, because, for example, in solar, you all come to know probably about the rebound effect, that, solar is incentivizing people to use more resources than they actually have, which leads to groundwater depletion and further issues down the line. So that's why, for example, water resource management seems to be a precondition in all of those projects, and overall in the way we approach solar water supply. It's also really important to have this pipeline for all of the WASH projects, because if you miss one of the steps, it will go awry in a very short time frame. We also think it's very important to plan, for maintenance, both to have, a preventive component, so to have dedicated resources that can do a round of your area of intervention, and to have also the means for water committees to do this punctual maintenance that they have to do. Also, we'll share with you in the chat the resource that ACF has been developing on solar pumping, because it kind of sums up the different steps and synthesize what we were trying to convey today. And as a final message, so I think one of the most important takeaway is that, we really need as humanitarian actor to consider water point as service, not just as an activity. And trying to really highlight and change the way we approach those things. It's not we've done it, we move on. We really need to consider it in a more holistic approach, I would say. Adam, you want to have the concluding word, maybe?
Oh, look, I think the last line in the final message here is a good one. Shortcuts create long-term failures, and copy and paste, might not be adapted. And if you're not checking a water point, 3 months after you're putting it in, is it worth it?
Definitely, I do agree.
Great. Thank you both for these very understandable messages and takeaways from this session. So we have heard 3 very different presentations on the use, experiences, and the feedback of solar technologies. Now we've got time for a Q&A for about 25 minutes. You're absolutely welcome to share questions in the chat for our 4 different speakers, and also to raise your hand and take the mic directly, take the floor to share a question or comments. You can also share your own experience if you'd like. During the last few days, we've also set up a question box online for people to share their questions autonomously. And we've received 5 of them, which are very interesting. So maybe we could start the Q&A with that. I will share 2 of them in the chat. It's on the situation in Gaza. The first one is about how can solar pumping systems be properly sized in Gaza when the field data cannot be verified due to access restrictions and damaged infrastructure? And the second one is what low-cost and open or open source tools can help humanitarian teams design and upgrade solar water systems in Gaza, given the very limited imports and rising market prices. Would you have any inputs or reactions on those questions? Adam, Alberto, Brice, or Vikash, feel free to take the floor.
Well, if nobody else wants to put their hand up, I'll have a stab at it. I can't really speak for Gaza, but what I can talk about is the solar pumping, how to properly calculate for it. There are some free tools online, such as the Grand Fos tool, which is a very good tool, as well as an ACF calculator as well. But the important part is, for most of these tools and calculations, is they're an estimate. They're an educated guess at the best of time. The only real way to be sure that the installation that you put in is correct is to be able to make it adaptable once it's put in, to be able to have a proper maintenance on this, and then the ability to change certain factors after it's already been installed. Those are the one true ways to make sure there's a system that's properly working, as opposed to calculate, set and forget, because, as you say, the information that you get is sometimes foggy at best.
Thank you, Adam. Is there other reaction from the panel? Maybe just to add to that, because it is true that one thing is the theory and another thing is the realities we face in the context. And I'm not familiar with Gaza, but we rarely have all the available data at the right time, with enough quality and the good budget to do things. That's often case the reality we face. And for the question in Gaza, what I will say is just speaking about the design, because for the other things, I think Adam touched on all the important points. But you will need to make some assumptions if you want to go solar, yeah. But if you have a pump, that is providing a certain amount of water, you can start working with that data to say, well, I'm going to assume that this water point can sustainably be exploited at that rate, yeah, because maybe it's a water point that exists there and is powered with a generator or the grid and is providing 5 cubic per hour a day and it has been working for some time, yeah. So you can start with that data that is one of the most critical ones, yeah. And what you want there is to just replace the powering unit of that water pump with solar panels, yeah. And for that, as Adam said, there are some tools. The Grundfos is one. If you are able to use good quality components that have the right manufacturing certifications, the difference between using a Grundfos pump or another pump of similar characteristics with the same manufacturing certifications are not that big, are not that important. So you could assume as well, okay, I only have the Grundfos tool, just imagine that, yeah? And I know that I need this pump, and I have this other that is also good quality and have the same very similar electrical characteristics and hydraulic characteristics. Okay, I could assume that is going to work to provide that amount of water, and I'm going to use those panels. And then you will learn from experience, yeah? You will make, perhaps if you have the right monitoring, you will see, where your design assumptions were not that good, and then you work on from there, yeah. But if you do enough installations in Gaza, which I don't know if that's possible, you will see there are similarities on the way we say you size system for different schemes, and then you will be able to do it better each time, yeah. That's what I would add. Sure. Yes. Thank you very much, Alberto. Yeah. I see there's a comment on the chat. Great. Thanks. I'd like to share as well in the chat 2 resources from Concern. because it was one of the organizations that we reached out to speak at today's session, but they weren't available. So they've shared with us 2 resources on solar drying in Afghanistan and solar pumping in northern Syria, if I remember well. And yes, if you're interested about those topics and these contexts, feel free to check out their studies. Now back to questions. I see there's another one. Actually, this really resonates with what you presented, Alberto. It's what are the challenges and the constraints between solarizing an existing pumping system that isn't based on solar power or designing systems built to operate on solar power? What is worth it? Creating one from scratch, transforming one that already exists and adapting it to the solar rising pumping instead? I feel like it's not a black or white question and it's probably complex, but would anyone like to give us more details about how to decide which one is worth it?
Well, I can give a shot to that one. I mean, I think it would depend on the context and your situation there, whether your finances, the time constraints, the quality of the things that are existing there. But apart from those that as I say, are context specific, one thing that came across many of the places that I visited and solar pumping schemes is that there was there was this tendency to use what is there, even though they didn't know, or perhaps the pump was not fit to the borehole because there was no pumping test done, and now we realize it's too big or too small, or it's a pump that is too old, or we have changed it in the past so many times because the quality of things. And we practitioners tend to use what is there because they think that is a more economical way of doing things. And if you see the cost of, for example, replacing an existing pump over the life cycle cost of a solar pumping scheme, it is so small, that I would say the focus is rather on other aspects like Adam mentioned, for example, the good maintenance, using quality equipment, having the right data, working on the maintenance scheme is going to give much more value for money than using an old pump there because is so that we save the cost of that component. That's what I would say about that.
Yes, makes sense. Does anyone want to complete Alberto's answer?
Perhaps I can just add that not so much one or the other in our program. We are only working in areas that have diesel pumps. But I should say that when you design the system for solar, sometimes it looks quite different from how it was designed for diesel. So typically, we find the solar pumps capacity may be, only 1/10 the size of the old diesel generator that was there. So for very many reasons, perhaps centralized procurement for diesel pumps in Ethiopia when the systems were built, we find 80 kVA kind of pumps, which take a lot of fuel, and the solar pumps we put in its place might be 10 kilowatts or 12 kilowatts or 15 kilowatts. So just to keep in mind that you do want to design with the basic parameters rather than just replacing one with the other.
Thank you, Bikash, for completing the answer. Great. We've also received a very different type of question, very interesting as well. It's been written in French, sorry. So we translated it, and AGR are income generating revenues or activities, sorry, income, generating activities. So do you have examples of such activities that you would recommend to implement around water points that are equipped with solar installations to motivate local staff to take care of the water point, to come by regularly, to bring people around, etc. Feel free to be creative. I see there's a hand up, but I don't know if it's for another question or if it is to answer the ongoing question. So, Idris, if you want to take the floor and let us know, you're welcome.
Yeah, good afternoon. I'm Idris from Nigerian Mission, Yobe, was program manager. Yeah, I want to respond to this question you said about income generating activity close to water point. I think for me, one innovative idea, particularly in our context here, is during WashCom training, we usually let the wash committee know that they can do a small wash garden close to the water point, and that they use the wastewater to water the vegetables, and sometimes they also sell it and get some revenue, or they use it personally, and that motivates them actually.
Okay, thanks. Great example, yes, of something very concrete on how to reuse the wastewater and generate revenue around the water point. Great. Thank you very much, Idris. There's another hand up. I can't see who it is. Hi.
Thanks so much.
Abdiaziz, hi.
Abdiaziz from Somalia, International Medical Corps, WASH coordinator. I really like the concept of our presentation on income generations using the additional the power that was not used with the water pumping, converting that power and using it to charging electricity, charging phones, lighting schools, funds. This is a very good initiative, and I think that answers the question from our colleague. That also adding the one for from Idris, yeah. In Somalia, we do also have vegetable gardens close to the boreholes and the Solaires boreholes. So these vegetable gardens provide vegetables, and at times communities sell it for operation and maintenance costs. Thank you.
Great, thank you very much. Yeah, great example as well. Is there any other feedback on this question? Yes, Manar, welcome. It's great to see there's so many comments from the audience. You're still muted, so we can't hear you. Or maybe it was a mistaken hand. I'm unsure.
I think he left the meeting, but it might have been a mistake.
Maybe they couldn't be heard. Hopefully they'll come back. Until then, maybe. Oh, yes.
Yeah, just to bounce back on what was said, like the two main utilization we see from the practice is like charging the phone, and also like using the wastewater for like small activities. There can be also like companies that need water, for example, for curing for their bricks, like for civil engineering. So often it can be like a complement, and there can be informal agreement with the water committees, like to use it as a complementary revenue. But it's kind of like it's traditional, but like the fact that you have constant stream of water makes it kind of relevant.
Right. Yeah, thank you. Yeah, and it does bring about opportunities to also drive social change and potential behavior change as well. So it's very interesting. Maybe another interesting question that we received in the question box. I'll post it now. What are the most effective ways to build reliable local capacity for installation and maintenance when spare parts, tools, and technical training opportunities are extremely limited? It's interesting because we had some insight this morning during the French session on training, right? Unfortunately, Renudis and Jean-Baptiste are not here this afternoon, but maybe our speakers from this afternoon also have some good practices or comments on how to train? Or anyone from the audience as well, of course.
I can give a shot to that one. I mean, there are a number of training opportunities already developed around solar water pumping in the context or for humanitarian context, let's say, like the one in. There is one asynchronous online on the Polytechnic University of Valencia. There is also the Global Water Center in the US that do training in French, English, and Spanish, and then a number of consultancies there. But what I would say, apart from that, is that I always think that training is good value for money. And you know, one of the weak points of our sector is that, the realities of our sector is that people rotate a lot. So you do a training in Somalia, you come back 18 months later, and you know, there is a whole new teams of WASP people in organizations, and so that is something that needs to happen in a recurrent way. But I also thought found that it's unrealistic from practitioners this approach of, well, you know, we install the solar pumping scheme, we do some training to the community, and so that warranty maintenance and goodbye. I think it was in the slide of ACF, no, this mentality of we install and we go, yeah, and we do some kind of training there. You know, the problem with that is that first you need for the kind of troubleshooting that you need for these systems, you need sometimes you know, technical knowledge that is not available at the community level, or is difficult to train people on in a couple of days or a couple of weeks. And the other thing is that by the time the problem might come, maybe it has gone 5 years after the training. Maybe the guy there is no longer part of the community, or he forgot, you know, everything that was said. And so I think it's unfeasible to assume that by providing training at community level, we are warranting the maintenance of these schemes in the long term. Yeah. So, you know, on that level of things, I think that attaching or linking the community to some kind of knowledgeable partner, whether it is, you know, the organization that installed it, a contractor in country, or, you know, the water office from the government, if they have this expertise, I think that's a critical point to you know, to maintain the system and to, you know, have always good people trained there for the small things. Yeah.
Yeah, thank you very much, Alberto. This makes sense, having knowledge available at different scales, different levels, from different places, to make sure it's always there somewhere and we can count on it. Abdiaziz, I think you had raised your hand first.
Yeah, thank you so much. I think my colleague has really put it well. The question is the capacity, reliable local capacity. These are some of the challenges that we face in solar installations in Somalia. Most of the solar installations fail because of lack of local capacities, and it has been a major contributing factor for failing of these huge investment solar installations. I think the best is capacity building of the local communities, not once, and having a refresher trainings maybe on a need base for the communities to capacitate them, so that in case of technical problems they are able to sort out the solar challenges. So my take will be having routine refresher trainings for the community, local community capacity buildings will be one of the best ways to make sure that we combat this failing of solar installations because of the capacity issues. Thank you.
Thank you. Great. Brice, did you want to add to that as well?
Yeah, no, but coming back to the like to the idea of systems, I think it's important also like to consider like the private actors, like formal and informal. And except in like very degraded context, you can always find like a technician or a small company or like some people that have like those skills that you can help structuring and incorporate after in your like maintenance scheme. So it can be also a way of like not working only directly with the water committees, but with the people that gravitate around it, and help them, train them, like have some livelihoods, integrated activities, for example, targeting those people can be a strong added value to, like have actually to create an ecosystem of maintenance also around your water ponds.
Right. Yeah. Thank you. Diversifying the sources. Vikash.
Yeah, I had a similar response as Breeze that, the people who are doing the maintenance need to have the incentive to do the maintenance. The capacity alone is not enough. So we are following a private sector model. So for the first 3 years, we expect the installers to take responsibility. Otherwise, they don't get paid their installment. But after that, we are looking at aligning some social enterprises, which perhaps will get paid when these systems work well. Because I think, capacity building can be a black hole. You can provide any amount of capacity building if the incentives are not there. One of the challenges we see with community systems is sometimes, not always, but sometimes the operators make more money when the system breaks down than when it works well, because when it breaks down, they get to go to town and buy materials and charge a per diem. So I think aligning the incentives so that the people who get paid when the system works would encourage, and put to good use any capacity building that is done. Otherwise, I think it can be wasteful.
Thank you very much. Coming back to the question of financing. I like it. Great. I see it's 29. Is there any burning comment or question from the audience? Any last word from our speakers who have been talking a lot? Thank you so much for bearing with all the questions. This has been a great conversation. Really appreciated the comments from the audience as well. All right. I don't see any hand, any word in the chat. So thank you very much, everyone, for joining. For the future webinars, so this next one will happen in March and probably another one in June as well. We'll be working at other topics and we'll make sure to send you the invitation. We try to, as much as possible, to have a more diverse panel than today in terms of gender. We've really struggled for today's webinars, and we really appreciate if in the future you have recommendations of women working in WASH that you'd like to hear or that think would be interested in participating in our webinars as well. So thank you in advance for that. And yeah, thank you so much again for your knowledge, for sharing it with us today. It's been great. And thank you everyone for joining as well in the audience.
Thank you very
Great
much.
afternoon.
Thank you.
Good afternoon.
Bye.
Thank you.
Thank you. Bye-bye.
Bye-bye.